Here we are with module 26. We're going to be talking about hypothesis testing now for a population mean. We just finished up confidence intervals and now we're moving into testing, which you have done with population proportions. Keep in mind as we work our way through this section, I'll be looking for you to understand and be able to use all 4 steps of the hypothesis testing process outlined in the grading rubric. I don't call it the grading rubric, I call it the hypothesis test. I think file, I'm not sure, but at the very bottom of this is a document, hypothesis testing grading guidelines for means and proportions. Each full hypothesis test on your final exam will earn 10 points max. To earn the maximum points, your hypothesis test needs to contain all of this information. So you need the state, which I've referenced multiple times in the mod, the plan component, the do component, and the conclude. And there's different scenarios that we're dealing with here. This is universal for means and proportions. So we're talking about calculating p hat versus calculating x bar versus finding the difference. So it applies to all the different situations. You just need to find the right one and move through it for the problem. Okay, learn by doing page 173. Which of the following situations calls for a hypothesis test about a population mean? Remember that a mean is about averages, not percents. This question says, a report of the College Board website stated that in 2003, males scored generally higher than females on the SAT exam. And the educator wants to check whether this is true or not. Now, we're talking about 2 populations here, males versus females. We would be talking about the difference between the two, not just a singular population mean. Part B, according to the Center for Disease Control, roughly 21.5% of all high school seniors in 2002 have used marijuana. A sociologist suspects that the rate for African American high school seniors is lower. We're talking about a percent here, which is a proportion. Part C says a certain prescription allergy medicine is supposed to contain an average, that sounds good, of 245 parts per million of active ingredient. And they want to check whether a mean concentration of pills is 245 or not. So is it different or not? This looks good. This could be a contender. Part D says a recent study estimated that 20% of all college students in the US smoke. And the health services suspect that it's lower. Again, that's percentage. So we're talking about C here. Okay, did I get this? You are asked only for the hypothesis statement for the following. The National Assessment of Educational Progress is administered annually to 4th, 8th, and 12th graders in the U.S. On the math assessment, a score of 275 is considered an indication that a student has the skills to balance a checkbook. In a random sample of 500 young men between the ages of 18 and 20, the mean math score is 272. Do we have evidence to support the claim that young men nationwide have a mean score below 275? Now we want to give the hypothesis in words and in symbols. Remember that we have our null, and if we're talking about our population average, we use mu. And we'll do the same for our alternative, but I don't know what symbol we're going to be using. The claim is below 275. So the claim is below 275. We'd use a less than and 275, which means that we're equal to 275 here. And the null is that we're talking about young men nationwide. So we would have the population mean of young men nationwide would be equal to 275. Our alternative hypothesis in words is again about the population mean of young men nationwide, and we're saying that it's less than 275. Let's revisit p-values, which represent a conditional probability as described in our hypothesis testing procedures for proportions. Remember that it is the probability of correctly rejecting the null when the null is false. Okay. An allergy medicine is supposed to contain an average of 245 parts per million of active ingredient. This manufacturer wants to analyze this. They've got a random sample of 64 pills, a mean of 250, and a standard deviation of 12. And that's for the sample. So then our N is 64, our X bar is 250, and our S is 12. Mu is going to denote the average amount of active ingredient pills in the allergy medicine. The null and the alternative is that the average is equal to 245 or that the average is not equal to 245. And we're testing at a level of alpha equals 0.01 significance. They ran the numbers and calculated a test statistic of 3.33 with the p-value very, very small. What's the correct conclusion? Well, remember, the test statistic of bigger than 3.33 Remember, we've got 68% within one standard deviation, 95 within two, and 99.7 within three standard deviations. This value is over here, which is very, very small. And so that's significant. And that means that the mean value, so what we're going to do is we're going to reject the null and we're going to say that there is a difference. But we need to say that it is not equal to. So this says is equal to. This says is equal to. This says is greater than, and this one says is not equal to. So let's refer back to our alternative, and we realize that it says not equal to, not greater than. So we're eliminating this and selecting B.